unit 46, embedded systems, right? So the unit code is this, and this is level 5 unit, and the credit value is 15 credits. So in this unit, actually, since it has 15 credits, and since it is level 5 unit, so this is extremely important, and not like the other modules. So in here we try to give you uh, more understanding on embedded systems, and how you can do the practical work. Right? So therefore all of you have to do these things, right? So is there any student who don't have a computer facility? Is there any student that who don't have computer, laptop or desktop? Here in this meeting, in the left hand side, there's three dots called more, right? In there you can raise your hand if you don't have a computer. I'm not talking about a mobile phone, right? Desktop computer or laptop computer. Can you raise your hand? Okay, so please raise hand for those who have either a desktop computer or a laptop. Please raise your hand and keep your hand raised, right? For those who have a laptop or desktop, please raise your hand quickly. Okay. Please keep your hand raised, right? Please keep your hand raised, right? Here, what about others? Sashika, um, BT 2021 number 2, Malsha, Rukmal, Leshani, Nalinda, Mihijaya. What about others? So, do you have, so if you have a desktop computer or laptop computer, please raise your hand. So, what about the others? Shashika, okay, Malsha, Charit, Imasha, Kandula, Shakti, Rukmal, Malsha, and Shashika. Please keep your hand raised, right? So I can count. So they are only out of 24 participants, only 16 as given. Malsha, what's happening with you? Okay, Rukmal, Shakti, Kandula, and yeah, Akalanka and Umesh. Please use the format that I have given you in order to. Uh, please rename according to the format that I have given you. Akalanka and Umesh, can you hear me? So please join with the format that I have given you. Okay, so use this format. For yeah, what about others? So Rukmal. Akalanka, can you use the format that is used by the others? BT, not dash, but a slash, 20 slash, 20 slash, so like that. And who is BT 2021 18? Can you use your name as well? So Rukmal, Shakti, Imasha, Akalanka, and Charit. So, what about you? So, do you have a desktop computer or laptop computer with you? Desktop computer or laptop computer? So, if you have a desktop computer or laptop computer, please raise your hand. Right. So, there's like three dots in your meeting at the right hand side. So, you can raise your hand using that. Here, what is your name? BT 2021 18. So Akalanka and what's happening with others? So Shakti, Masha, Charit, you have a laptop or desktop computer? Charit, Timasha, Shakti, and who is BT 2021 18? Can you use your name as well? All right. So um, so Charit, Timasha, and Akalanka, you don't have laptop computer or desktop computer. So if you have a laptop computer or desktop computer, please raise your hand. Okay. Umesh, Akalanka, Imasha, and Charit. So you don't have any laptop or desktop computer, right? Is that you meant? So if you have a laptop computer or desktop computer, please raise your hand, right? So that is the question. Okay. Who is BT 2021 03? Please use your name as well, the format that I have given you. So here, Chatup, Mihijaya, Sanduni, Imasha, and Charit. So if you have a laptop or desktop computer, please raise your hand. Right? If you have a laptop or desktop. Okay, Shakti. So you are correct. So Chatupa, Sanduni, Imasha, and Charit. So do you have a laptop or desktop with you? So in that laptop or desktop, you should be able to write install and software and everything, right? Because for this unit, you need to install few softwares, right? Yeah, I will give you few the names of few of them, right? But for and some of the others will be given by Mr. Hasita, right? But and according to the conditions that we have, we don't know um, when we can start uh, when we can start the meetings, uh, start the hands-on practicals, right? So therefore it is better to it is better if we can previously do these things in in your computers, then we can do it uh, when the classes start. Right, so Chatupa, do you have a laptop or desktop? And the Sanduni and Nimasha, do you have a laptop or desktop? So according to this, you don't have. Okay, Chatupa, you have raised your hand. You have, right? So Sanduni and Nimasha, do you have a laptop or desktop? So if you have, please raise your hands. If you don't have, so that means you don't have, right? So Sanduni and Nimasha, you don't have laptop or desktop. Is that so? So number 19 and number 39, you don't have laptop access or desktop access. Right, right. So yeah, you can lower your hands, right? You can lower your hands. Right. You can lower your hands. So Okay, give me a minute while I take your attendance. Okay. So here, can you all see this? Yes, right? um, so this is embedded system and the unit number is 46 and this is level 5 unit, right? Mm, Here I have put like 20 sessions. 20 sessions means like 3 hour 20 sessions or 6 hour 10 sessions, right? Because when it comes to the other lecturers classes, so he will be doing most of the time the 3 hour sessions, right? So today I will do 2 3 hour sessions, right? um, Here I have planned to give you one assignment, right? One assignment for this one, but then I thought to give you two assignments because otherwise, uh, otherwise, so I got that thought now because otherwise you may not be able to do it as we require, right? I will most probably you will get one assignment or else you will get two assignments most, right? And here these are the softwares that you need. Here this is MP Lab, right? MP Lab, Proteus, and the Arduino, right? Arduino one. And when you are working with MP Lab and Proteus, um, you don't require any other uh, any other what we call you don't require any other hardware, right? But if we are going to continue, right? If we are going to continue with this, uh, you may require um, Arduino Nano board, right? Arduino Nano board. So apart from this, right? Apart from this, um, um, there's one called micro C. Right? And apart from the hardware required, big 16 8.4 and the Arduino, you may need big 16 F. I need to check. Double 8 7. 887, right? So these things you may require. Right. MPLAB, Proteus, then the Arduino IDE, and also you need micro C. And in the hardware wise, you may require PIC16F84 and the Arduino Nano, right? Arduino Nano and PIC16F887, right? So those are the things that require. Actually, we cannot work with the hardware. We cannot work with hardware until the classes starts, right? But if you have, most of you may have this Arduino, right? Arduino Nano board. So it would be better if you can use Arduino Nano as well. So I think almost all of you have an understanding on Arduino Nano, right? Because it can be used for anyone like older than 8 years, right? Arduino board. So you should have if you have it, so we can try more um, try more on Arduino Nano, right? So so let me explain, right? So give me a moment. Right. You can all see the what I'm writing in here, right? Okay. Okay. So we need uh, micro C apart from these things, right? MPLAB, Proteus, and the Arduino IDE, right? And apart from these things, we may require PIC16F 887, right? 887, right? So we need Arduino Nano, right? Actually, in order to complete this module, so you may require at least one of these things, right? Because in this assignment, what you have to do is actually, right, if you have one assignment or two assignments, okay, one or two, in a in one assignment you may have to implement, right? You may have to implement uh, some embedded system. Right? You may have to implement embedded system, right? Embedded system is actually the one with some sensors and plus some actuators, right? Sensors plus actuators you should have, right? So therefore we are going to use at least one PIC16F84 Arduino Nano PIC16F887 in order to this implementation, right? So this should be done by yourself, right? So therefore in order to use these things, right, in order to use this MPLAB, Proteus, and Arduino IDE and Micro C, right? Actually using MPLAB, right, Micro C and Proteus, right, we can do all the simulation that require, right? We can do all the simulation that we require. So uh, uh, so therefore these things actually, when we are doing our online lectures, we don't require by this time, right? By now we don't need, right? But we will need it later, right? So MPLAB, Proteus, and Micro C, so these are the main things that we are going to use in this course, right? We are going to use in this course. Okay, so any questions? Madhusha, please use the format that I have given you, right? So your BTech number and your name, right? So I have given it in our WhatsApp group as well. Use that one, okay? Any questions? right? So these things we require, right? So MPLAB, Proteus, and the Micro C at first we need. That means maybe from the next lecture, uh, maybe from the next lecture we are going to use them, right? MPLAB, Proteus, and Micro C. I suppose that you have idea on working on Proteus, right? And most of you have an idea on working on Arduino, right? So, okay. Uh, Please raise your hand if you have worked with Arduino previously. Please raise your hand if you have worked with Arduino previously. Most of us have worked with Arduino, right? Can you please raise your hand? Um, yeah, this is MPLab IDE 8.92 version, right? So I hope that all of you will install this one when you come to the next class. So then we can do um, the practical and everything while we are on the Zoom meeting, right? Uh, so that is our plan. Um, so this is microchip MPLAB body. So here this is 8.92 version, right? But here there's another MPLAB body, but I'm not familiar with working this one because this one will give you a good understanding on and this one will give you a good understanding on the how to work with microchip. That means so you may have heard like the PIC microcontroller. So they are manufactured by Microchip, and this is their software. Right? So this is their software. So therefore we can use it. So this red color and blue color logo is its logo, right? So use uh, install this one into your laptop so desktop. So then on the next time we can work with this. We can work with this, right? So that is the one software, right? That is one software. And so then next one is this micro C, right? Micro C, right? So I have installed a free version of it. So I hope all of you can find a free version of this micro C, right? Micro C, in this one, why we are using it is um, in order to high level um, uh, we use this to actually do high level programming, right? High level programming. So therefore please install this one as well, micro C, right? Micro C. So the MP lab and micro C, they are same. Actually they are some IDs, two IDs. In MP lab we are doing actually low level programming. That means we are more close to the equipment level, but in micro C we will do it in like what we call in high level programming, right? And next one you have used, right? Proteus, right? Proteus. um, okay, Proteus, right? So Proteus software, so install this one as well. Install this one as well, Proteus software. So Proteus is what we can do is actually uh, we can build the circuit in Proteus, right? We can build the circuit in Proteus and we can write the program that we need uh, to our circuit using MPLAB or Micro C, right? We can use MPLAB or Micro C. So after using MPLAB or Micro C, what we can do is actually we can put that hex file into the design circuit microcontroller, right? Then we can simulate. So if it simulates, that means it there's like a possibility that it will work when we have implemented them in a lab class, right? So therefore make sure to install this as well. And the next one, this Arduino IDE, right? So in order to work with this Arduino IDE, so it is better if you have a Arduino Nano board, right? So Nano board is enough for your project as well, right? Project as well. So Arduino software, right? So we need this Arduino software as well, but um, for now we don't need, right? So we'll need it like in after 2 or 3 lectures. We need this Arduino IDE as well, right? And the Arduino board. So in Arduino board, we are going to connect it using uh, we are going to connect it using in the USB, right? USB connector. So, but for now, what we need is that MPLAB IDE and Micro C, and also Proteus, right? So most importantly we need Proteus, right? So I hope all of you have installed Proteus, right? So for the other softwares, right? So please install them before the next lecture, right? So then while we are doing it, we can do it, right? We can do this, and and for each day I will give you some submission, so you have to do this and submit to me, so then I can check it. So likewise, right? So then we can move forward effectively. Otherwise it is no use that there's like only one way communication is happening, right? So therefore we will use it like that. Okay. um, we will do it like that. So most probably the Mr. Hasita, he will also do the same thing, right? That means so he will ask you to do some tasks, right? While doing the class, right? So uh, then you can proceed, right? So actually at the end of this course we expect you to implement something. That means you have to implement it physically, you have to implement it. So when you physically implement those things, you have to present it as well, right? So at the end of this unit, so therefore we are going to assess that one, right? Assess that one. So uh, probably we may use this Arduino one, right? But actually it can change, right? So you may be able to use PIC 16F887 or PIC 16F 84, right? So uh, when we are talking about it, right? So I will show you how it looks like, right? So this is how it looks like, right? So after install it, this is how this MPLAB ID would looks like, right? So yeah, I am asking you to install a lower version because we can understand a lot of things, right? In here, so actually in here we can actually start a new file, then we can write our code in very low level means we are very close to the machine level, equipment level. That means it is like we are programming it while um, observing the big microcontroller, so something like that. So therefore um, that is how how we are going to do it, right? How we are going to do it. So first of all, you have to install this MPLAB ID and everything, right? um, then for uh, for the for the other ones, right? So like we have we will use micro C a lot, right? Right. Okay, I will show you that software as well. It's still loading, right? So okay, now right here this is Micro C Pro, right? This is Micro C Pro. So I have installed a version, right? So in here we are using this one in order to some high level programming, right? So first what we are going to do is we'll do we'll understand the concepts and everything uh, in with the aid of the MPLab IDE, right? In MPLab, as I have told you, we are more close to the equipment level, so therefore we can learn many things when we are using MPLab, right? So therefore, after getting an idea what is happening inside this, we can move on to we can move on to like in order to do uh, programming and simulations using micro C, right? Both of the softwares and everything, they are extremely easy, and here you have to follow this course very carefully, right? Because there are a lot of things that you have to learn, right? So as I have asked from you, there's about like 1/3 of students has worked with even Arduino, right? So therefore, these things may be new to you, right? And at the end of this course, you have to submit an implementation as well, a design, and of, after you have to implement that design. So therefore, as the assignment, right? So therefore, this is extremely important for all of you, right? So therefore, mm, uh, please make sure to install these, right? Install this. So the other one is you have seen it, right? Because you have worked with Proteus. So for your course, Proteus is also very important because in here actually we are more focused on the standard method of product development. That means, let's say, in here you have to do develop an embedded system, right? So before we develop it, what we are doing is first of all we will design it, right? Design it, then we will simulate it, right? Simulate it, and before a mass production, what we are doing is we will do the prototyping. So what you are doing is the prototyping, and before the prototyping you have to do the simulation part, right? You have to do the uh, simulation part. So I will show you, right? um, so you should work with Proteus. So right? So this is Proteus, right? This is Proteus, and one other thing, if you are working with Arduino, you have to install the Arduino library to this one, right? You have to install the Arduino library to this one, but for now we don't need, because here if we just check the library, the PIC 16F84, here it is available, right? PIC 16F84, that is available, and also PIC 16F887, that is also available, right? In here, so you can check PIC. So this is PIC 16F88, PIC 16F84, right? And here the other one, PIC 16F887, it is also available, right? So therefore, up to now it is enough, right? But make sure to install all these softwares by the at least. So you have to install the softwares that I have told you. So I will close these things, right? So you have to install MPLAB, right? By the next class, you have to install MPLAB, Proteus, and Micro C, right? So MPLAB, Proteus, and Micro C before next class, right? Before next class, right? Uh, before next class. So that means before lecture 2, right? Then this Arduino IDE you have to install before lecture number 3. Before lecture number 3, you have to install Arduino IDE, right? That means this one, Arduino IDE. Then try to find the Arduino Nano board at least, right? Um, so if you don't have it with yourself, so try to borrow from uh, some of your friends, right? Some of your friends, and so yeah, this should be installed before next class, and this should be installed lecture number 3. And why, when you are installing Arduino IDE, right? Uh, make sure to install, right? What do you call Arduino library to Proteus, right? So this two before lecture number 3, right? Arduino library to Proteus. So you can install Arduino library to Proteus, because in default Proteus you don't have the Arduino library, so therefore you don't have this Arduino board. So Arduino Nano is the one that we require, so therefore Arduino Nano is enough, right? So before lecture number 3, right? Before lecture number 3, install Arduino IDE and Arduino library to Proteus. So this one, right? So by before the next class, that will be on next week, you have to install MPLAB and Proteus and the Micro C to your laptop or desktop, right? So to laptop or desktop, right? Then um, then I have told you that you have to do the implementation, and for that implementation implementation, find at least the Arduino Nano board, right? So I'm telling this one now because you have like we'll give you the assignment like after 8 weeks or something, right? So then you have at least 8 weeks, so 9 weeks from now in order to find this Arduino Nano board, uh, because otherwise we cannot find it, right? Find it. If you ask to do it in like 1 or 2 days, you cannot find, right? So it is obvious. So therefore find this Arduino Nano board, right? Arduino Nano board. So if you have like Arduino Mega, right? Arduino Mega, that one is also all right? Arduino Mega is all right? But here this one is enough. So this is more expensive than Arduino Nano board. So Arduino Nano board is enough, right? So here, even our practical and the lab classes started, you need to do these things by yourself, right? Why? Because everything that we are doing, you have to test it, right? So even so, uh, without considering whether the classes will start like in face-to-face classes will start or not, you have to do these things, right? So you have to install these three, right? You have to install these three before lecture number 2, and you have to install these two before lecture number 3, right? And you need to find this Arduino Nano board. Like you have like 8 to 9 weeks time, right? Even though we started our courses or not, right? um, mm, why we need require this Arduino Nano board is because we are doing an implementation, right? So in that implementation you are going to design something, right? Design something. So in that design there is an Arduino board, right? And that is done by your devices, right? The devices and the components by yourself, because uh, in order to have this only let's say like a breadboard is enough, right? In a breadboard you can put this uh, the components, you can connect it on the breadboard, and also here you have the Arduino Nano board. So from that one you can connect it to that, right? So therefore uh, like that, right? And um, as I have told you, I will do only the like maybe like 4 or 5 lectures in here. The rest will be done by our next lecturer, Mr. Hasita, right? So therefore you don't have to worry about everything will be covered in this one, but make sure you are taking everything from this module, right? So it's embedded system module. And here for the Proteus, so there's like a portable version as well. And portable version means so you can keep it in, you don't have to install, yeah, you don't have to install because everything is inside that folder, right? So you can just start Proteus, and you can use it. So I'm using Proteus a portable version, right? So like that. But for MPLAB and Micro C, so make sure that you are installing the correct version, right? So because if you just type MPLAB IDE, you will get, right, you will not get that red color and the blue color one, right? Red color one and the blue color one, what you will, right? You will not get the red color and the blue color one, right? You will get something else, right? So for that one also you can work, right? But I am asking you to install this red color one and the red color and the blue color one, because it is easy to work with that. It is simple to understand. Simple to understand. Uh, so search for these things, so you will find, right? You will find these things internet or anything, right? So then install it into your laptop or desktop before the next lecture, because in there, what I will do is actually I will give you I will show you some examples, then I will give you some task, right? Then you have to show me your work by doing it by yourself, right? um, so that is the most effective way that we can do this embedded systems module, right? So do you have any questions? Any questions? Okay, so you don't have any questions, right? So we will take our tea break, and by like 11:15 or something we'll start again, right? 11:15 or something, 11:15, right? We will start again, right? So then we'll take the break, right? So if you have any questions after the interval, so please ask me, right? So let's take a look what is this module is about, right? So what is meant by an embedded system, right? Embedded system means, so it is a device. It is not a multi-purpose um, device. So it is actually a single purpose, and inside this there is a microcontroller. So with that one we will understand what is an embedded system. So this is our uh, microcontroller, and this is single purpose device, right? Single purpose device, that means this device has one objective, right? One objective. So one objective, so not like it is not a multi-purpose. It is not a multi-purpose, right? Multi-purpose, so it is a single purpose one. That means it is designed to address a single issue, right? Or in order to address a single task. So that's why we are using embedded systems, right? So if we consider, so um, almost all the devices that we are using, they are the electronic devices that we are using, they are embedded systems. So they are applied in actually automotive, medical, industrial, in homes, offices, and everywhere we are using these embedded systems without knowing that they are embedded systems. So why we are focusing on embedded systems is because in the next era, right? So the next era, what we have is actually only three things. So one is artificial intelligence, the other one is the big data, and the other one is cloud. And the things that we are adding to this one is, one thing is, it is called IoT. IoT is called the Internet of Things. And uh, mm, and uh, in there we have M2M. M2M means machine to machine communication. So mm, so when our classes started, right? So I will arrange you visit for this our IoT setup, right? So in our training center we have an IoT setup as well, right? So in IoT setup means, so we have devices, right? Several devices. So um, we are connecting them together, right? And they will work, they will coordinate by themselves. So in there, actually, there will be a machine to machine communication. M2M means machine to machine communication without our involvement. Right? So previously what has happened is, so previously what has happened is, we are the one that is in between, um, machine to machine, right? We are doing the communication between machines, but with M2M communication, they are doing this communication by their self, right? So as an example, mm, uh, let's say, something like this. So um, uh, let's say here we have a measuring device temperature measuring device, and here let's say we have a uh, ceiling fan, right? So by observing the temperature from our device, right, what we are doing is we will adjust the speed of the fan, right? But but now, so this is simple example, but with M2M communication, this can be done by automatically. And also, not, this is very simple example. Not only that, each and every device has communication to each and every device in the network. So so by staying in only at one place, we can control many things, right? But now actually this control that we have, right, it is given to the machines. So previously these machines are actually some they are dumb devices, right? Dumb devices, but now we are giving intelligence to them. So intelligence to them, so therefore they will work as they want. So they will do the communication with, with themselves. Then also we just have to do some monitoring part, right? Actually, in order to do this monitoring also, we can use another machine, so something like that. So when it comes to like smart homes and everything, internet of things is the biggest one of the biggest area that we have to address, right? So giving intelligence to machines is, so actually we are in the path of this artificial intelligence. So in artificial intelligence, actually now we will give the knowledge to the machines. So knowledge and not knowledge, intelligence to machines, intelligence to machines. And big data means, so when we have lot of devices, so they will have large number of data, large number of data, right? And the cloud means, so in order to access, now our data is not local, actually they are in the cloud. So we can access, if you anyone in anywhere can access to this data in the cloud, right? So these are the major trends, and associated with these things we have IoT, M2M communication, and a lot of things associated with this. So therefore, embedded system, it is a key area, right? So in our modern engineering means, so in the state of the art engineering, this embedded system plays a vital role, because the IoT, internet of things, so all the things that you are connecting, they are embedded systems. By embedded system in this machine to machine communication, they are embedded system. So I have told you that we are giving them some intelligence. So that means those embedded systems, so they can actually do lot of things. A lot of things means like the communication and all, everything, by doing their specific tasks, right? By doing their specific task. So in this module, that is what we are going to address, right? So actually you need to uh, in this one you need to actually read and read lot of things, right? In a lot of things, right? So you have to actually research how these embedded systems affect in the present and in the future by taking all aspects, right? Like AI, big data, cloud, IoT, machine to machine communication, all sort of things you have to take into account. Okay. So this module is divided into four, right? Actually, these are the four uh, learning outcomes, right? So the first one is the introduction to embedded systems and microcontrollers, right? So in here, what we are doing is actually, so another thing that I need to tell you, right? So if this is a 15 credits unit, right? 15 credits units, and in here, in most of the subjects, we have like 60 hours of uh, GLS. GLS means guided learning hours. That means this is where you have your lectures, practicals, and everything, and the rest 90 hours, right? 90 hours. These are non-guided learning hours. That means uh, GLH, right? Non-guided learning hour. That means this is the part that you have to do, right? So in this module, right? Maybe we may increase this number of hours more than 60 sometimes, but the major thing is actually in here, this part, the part that has to be done by yourself, it is higher in this one. So at least you should spend like 1.5 times of time than the guided learning hours for your own work in this module. And so here, introduction to embedded systems and microcontrollers. So what I will be doing is I will introduce what are the embedded systems, and I will give you a task as well in order to figure out the embedded systems and what are they. So something like that in learning outcome number 1. And in learning outcome number 2 and 3, actually they are interconnected. They are interconnected. So interconnected means, so microcontroller programming, design and implementing microcontroller circuits. So this involves this programming part, implementation, and also the simulation, design and everything, right? So design, programming, implementation, simulation, design, programming, simulation, implementation, and everything is in these two learning outcomes, learning outcome number 2 and 3. So this is where you have to design and implement embedded system. Right? In this learning outcome number 2 and 3, right? So you will gain some knowledge on the embedded systems and what microcontrollers are, and by applying that knowledge you are going to uh, figure out this microcontroller programming and the design part and the implementing part and the simulation and everything. You are going to figure out it in here, so with the task, right? So we will give you just a brief introduction, right? So for most of the things, then most of the content you can find it in internet and in tutorials, so therefore you don't have to worry. In order to design this embedded system, so you can find the required knowledge and everything using internet, and also referring some books as well, right? Then in the fourth one, in here actually we have the research in part, right? Research part. So evaluation of applications of embedded systems in the wider environment, right? Evaluation of applications of embedded systems. So what is the evaluation, right? Evaluation applications of embedded system in the wider environment. So this is where you have to address the things that I have told you previously. So here you have to address actually from past to present, then from present to the future. Future means this is actually you can address like near future as well, right? So everything should be considered um, when you are researching about the applications of embedded systems, right? So here this can go into mm, wider environment. That means even in like this transportation, uh, transportation area, and in like, so let's say like in education, so those things as well. Not only this industrial and everything, you have to go in wide area and you have to research this sort of things. So this is how a microcontroller would look like, right? Microcontroller. So here these are the actual learning outcomes. Explore the principal features of a microcontroller and explain the purpose of its constituent parts, right? So if by taking the microcontroller, right, so first of all you have to understand what is embedded system. Then inside embedded system, as I have told you, there will be a microcontroller, right? And in this microcontroller, there will be many parts inside this microcontroller. Okay, there will be many parts inside this microcontroller, so you should be able to explain and understand what are the purposes and what are the tasks that each module is designed for. Then the next one, design and implement simple external circuitry interfacing with given microcontroller. So yeah, this is the design part, right? So in here actually you have to uh, write the well structured code. So learning outcome 2 and 3 they cannot do separately, right? So because in designing part you can do, right, but implementing and the simulation part, it will include the programming and debugging and simulation and everything, testing and everything. So therefore learning outcome 2 and 3 they come together. So therefore when you are writing the codes that require in order to implement your embedded system, they should be come 2 and 3, they should be done together. Right? Then fourth one, evaluate the applications of embedded systems in the wider environment, including in network systems. So as I have told you in previously, that thing also you have to address. And and in here, right, in here um, both of us, the both lecturers that is assigned in here, they will contribute to all these learning outcomes, right? They will we will contribute to both of us, me and Hasida, we will contribute to all these outcomes, right? All these outcomes we will contribute. So it is not like I'm doing first one and second one and he's doing third one and fourth one, because actually it is hard to separate this 2 and 3, right? Yeah, 2 and 3. So they, as my thinking, this 2 and 3 this should come together. Right? Then the first one, actually this is actually very um, we called a sequential unit, right? So here in here you will have the introduction, everything, and in here you have the design, uh, implementation, and testing, right? In testing means you are getting some results as well, right? Then in here you have the uh, evaluation, right? Like that. So this is very well organized unit. So you can go along this unit like this, right? And mm, yeah, something like this. So you have to why in order to do this implementation, why for the what I'm going to do is actually most of the time we will use Arduino Nano board, right? Why we are using Arduino Nano is actually because it can be like you just need the USB uh, cable to connect it, right? So if you connect it to just your computer or anything, so you can see all the things using that one, right? So sometimes if you are connecting any other device, then it may require sort of like some sort of like external power. But apart from that, it can be powered by this USB cable and everything, and all the required modules are available in this Arduino, right? Arduino. And so if we require some sensor or anything, so that may be like very few sensors and actuators you may need, right? Because like in the Arduino development board, you have like LEDs and some outputs that you require, they are already inbuilt. So therefore it is easy to work when we are working with Arduino board, right? So before moving to next one, right? Any questions? So you can use the chat as well, right? You can use the chat as well. Any questions? Okay, so one has asked, so how much time that you given to complete this? So actually, in order to this, complete this, actually like 2 weeks time period is completely enough, right? 2 weeks time is it is enough. It is enough, right? So using that 2 weeks time, you can do it. Actually, first of all, what you need is you need to just simulate the things, right? You can simulate all these things, then you can implement, right? Then you can implement, and implementation it involves like very few things, right? And the code that you are going to write is actually most of the time what you are doing is we will use like existing codes and everything, right? But with the understanding, right? So because yeah, you using libraries means actually it is again using codes from someone else's, right? Same thing, same thing. That's why we call it as a library, right? So first of all what you have to do is install those softwares and everything, right? Then find out this Arduino Nano board, right? Arduino Nano board. uh, so you don't have to return it to us, right? At the end of your assignments and everything, uh, assignments and everything, you can just show it. You can just present what you have done. Right? You can just present what you have done, right? Um, so therefore try to find this Arduino Nano board. uh, Anything else? Any other question? Oh, you're asking, will there be lab classes, right? Yes, we will try to conduct lab classes, right? Lab classes if the government permits us to do the classes, right? If the government permits us to do the classes, so so otherwise we cannot start classes, right? By the timing that we have now, at least it will take like more than 1 or 2 months before we before in order to start the classes, right? But actually we need to finish your modules and everything, right? Therefore we cannot wait that much long, right? So therefore you can install that, but you will get all the experience that you require by following this course from A to Z, right? So you like that. Okay. um any other questions? Okay, so you are, so is it compulsory to attend all lectures? Yes, it is. It is compulsory to attend the lectures and practical, because if you miss on one day, then I suppose you won't be able to mm, you won't be able to catch that on the next class, because we are proceeding in one after another, no? So something like that. Because of that, um, anything else? Okay. What are the sensors and actuators that you need, right? Um, so I will just give you a brief, right? So we need temperature and humidity sensor, and then we need like servo motor, right? And we may need some LEDs, right? Uh, like that. And this Arduino Nano board. So those are the things that we may need, we may require, right? So if you have found this Arduino Nano board, the servo motors and temperature and humidity sensors and LEDs, they are very easy to find, right? So trying to find this one as well. So as I remember, this is DHT11 sensor, DHT11 humidity and temperature sensor. And yeah, some you may need like LDRO as well, right, in order to sense the light intensity. Something like that also you can need. And what are the other things that you need is, you just need like the jumper wires, and for the power supply you don't have to worry, you can supply power by USB cable. So any other questions? Yes. Okay. Will there be two assignments or one assignment? So yes, I will try to separate it to two assignments, right? um, why is that is actually, yeah, if I am doing it, I will do it something like this, right? So this first three learning outcomes, I may give you one assignment, and for this one I will give you another assignment, something like that. uh, because learning outcome number 2 and 3 we cannot separate, and learning outcome number 1, it is good in order to proceed for learning outcome number 2 and 3, because first of all you have to explore and everything. then you can move forward, right? Then you can move forward. um, I will try to separate it like this, right? Evaluate the applications of embedded systems in the wider environment, including in network systems. So I will try to give it as a separate assignment, right? So learning outcome number 1, 2, and 3, right? So they will be like together, right? Give me a minute. Okay, so unit 46, LO 1, 2, and 3. I will give you like one assignment, and LO 4, another assignment. So like that we can do. And thing else. Yes, so as you know, we are so in your course we are so fast like this. So this, yes, only the level 5 units are considering in order to calculate your grade. Yes, in order to calculate your final qualification grade, level 5 modules are considered. So take a look at the student guidebook as well, right? In there, if you have obtained for level 5, let's say 15 credits unit, if you have obtained a distinction, you will get 15 into 8. 15 into 8 is 120, right? 120 marks if you have obtained a distinction for 15 credit unit, right? And so you have unit 34. Unit 34, it is it 120? Yes, 120, right? Unit 34, it is 30 credit unit, right? It is a 30 credit unit. So therefore, for 30 credit unit, you will get like 240 marks, right? When we are calculating the grade. And If you got like more than 840, as I remember, 840, you will get a distinction, right? So that will be your overall grade. Yes, that will be your overall grade. Yes. Yes. So, okay. So the other question is, so, yes, the timely submission of these things, right? Timely submissions of these things. So actually, the in the like external verifiers meeting also, you have provided some feedback on how these submissions are going to take place, right? So what we will do is actually we are planning to make a different email address for each unit, right? Then you have to submit it on the particular day, right? On no before that date, right? Your reports and everything, and then we are going to assess it afterwards, right? So otherwise this will be like so as you already know, in if you were given like a timeline like this in order to submit like 2 weeks, so after this point you can submit for a 1 week of time, but it is will be a delay submission, and delay means you will only get a pass mark, and after this point we are not going to take your assignment. So because of this online submissions and everything, we had some flexibility in here, but actually now we will try to um, avoid that one, and we will try to stick into this time plan. Yes. What are the recommended textbooks, right? So here I will show you the recommended textbooks. Right, so this is your unit, right? You can see it, right? So this is your learning outcomes and assessment criteria. Yeah, there's some question as well in here, right? Because here can you see that LO3. I don't know whether it is some kind of a mistake. Hmm. Maybe this is for LO3, right? So if that happens, I cannot separate. Yeah, these are the recommended textbooks, right? So here for Arduino, this you have this Arduino Explore in Arduino, right? Then for the like uh, microcontrollers, that is this one, right? uh, in our center we have like ARM microcontroller as well, called embed board, right? Embed board. If we had the time, we will do some kind of introduction to that one as well, or otherwise we will do it on Arduino, right? Arduino and this PIC microcontroller. So for the PIC microcontrollers, It is these principles and applications of this. Mm. Design in embedded system with peak microcontroller principles and applications. So peak microcontroller. So here these are addressing three microcontrollers, right? One is the peak, and the other one is the ARM microcontroller, and the other one is the uh, Arduino. Arduino. Yes. Uh, okay. Any more questions to me? Okay, so where we can find these textbooks. So actually you have to search it, right? You have to search it, and so you may know, right? This is called there's some site called, so you may know, right? um, Library Genesis. From this one also you can find. Right? From this one also you can find from Library Genesis. Yes, from that one you can actually find it. Yeah, Library Genesis. In here you can find these sort of books. Um, okay, where you can find any assistance for level 5 units. Okay, so that one also, before we move further, I will explain that one as well. Right, in your student guidebook also I have given you this, right? um, how many of you have access to HN Global? HN Global means it is called the higher nationals, right? Higher nationals. In that higher nationals, your higher nationals, um, you can go there and you can make a free account, right? So next, another question: Do uh, mm, we do the hardware implementation if the physical classes start? So we should implement those at homes and send it in appropriate way. Okay, yes, for the presentation and everything. For the presentation and everything, um, you have to do, so somehow you have to do the implementation, right? So actually, as I have told you here, it require minimum number of resources, and you have to provide those resources by yourself, right? If the classes starts, we can give you a place to work with that, right? But the components you can keep it and everything, so therefore we are going to provide those components and everything. um, and after implementing that one, if we were unable to start classes, right, what we will do is we will have like a, so we will have like a presentation, so you can uh, you can do a presentation, and in that presentation you can switch on the video and you can show it to the assessors, right? You can show it to the assessors, right? Something like that. And but all the design and implementation and everything, that should be included in your report, right? Yes. The design, and how you design, how you simulate. Um, and okay, for some students the chat was disabled. Yeah, you have fixed that one, right? So now you can send, right, your questions, right? Now you can send your questions, right? For some students the chat was disabled. uh, okay. Even though you are doing the physical implementation, so that is actually evidence only, right? That is only as evidence, right? That is only as evidence, but the report should contain everything, how each and every step, and each and everything that should be included in your report, right? So and the even the images of your design and everything, also images of the implemented design also, it should be included. Um, it should be included, right? Mhm. Um, so as an example, let's say the code actually you have to include, and how you designed it, that design diagram you have to include, and the Proteus simulation you have to include, right? And after completely implementing it, um, after completely implementing it, again um, you have to include images of that one into the report as well, right? So some kind of thing like that you have to do, right? um, and uh, we are checking the presentation and everything, the presentation of your implemented design, because in order to check whether you have done it, in order to check whether you have done it correctly or not, right? And you have actually done it or not, right? So that is what we are going to check in that presentation. Okay. Okay, so here I will show you another thing. um, so here in your student guidebook also it is given HN Global, right? HN Global. So if you just type higher nationals HN Global, you can go to this, right? So here I have made a student account by myself, right? Student account by myself, right? So you can freely make an account in here. So I have freely make an account called Manoj Herat, like this. So then you can access to this HN Global. So since you are going to finish your program, so it is better if you have an understanding on this one as well. Actually, it you will get more support if you have interacted with this one previously as well, right? So in here there are some core textbooks. So core textbooks we have in here, right? So business, computing, art and design, construction. Here we have engineering core textbooks as well, right? um, Volume 2, right? Okay, so here when you have this, you have to make account called a vital source account as well. Vital source account in vital source. So when you go to that HN Global, right? So how to go to HN Global? Just type mm, uh, HN Global, right? HN Global. So the first result that you're getting is this HN Global, right? And in there you can go and make an account as well, right? Then you can go inside that. Then inside when you go to there, so in order to go to this engineering core textbooks, you have to make a vital store account as well, right? So in here, so it will take some time. Okay. Okay. Mm. Can you see this one here in the table of content? So there are main important units as well, right? Here unit 34. Mm. The unit 34. So you have that research unit, right? Research unit. So it is starting this semester. Um, Here chapter 1, taking on a research investigation. Right? So those things it is included in here, right? It is included in here, right? Here can you see that there are a lot of chapters. Here planning and managing time, working successfully, supervisor finding relevant source material. So like that you can find a lot of resources, right? Yeah, presenting your project assessment and acting on feedback and everything is in here, right? So therefore it is better uh, to go here and create an account, right? So if you need any assistance, please ask from me, right? I will tell you what to do, right? Mm. Yeah. If you have any questions, please ask from me, right? So I will assist you. And here for unit 35 also you have, right? I don't think you have um, unit 35 in this semester, right? If you have it, then you don't have, right? um, yeah, there are help for you, right, in here. um, they have updated only for the core textbooks, but here referring this research project is, it is vital, right? Why? As I have told you, it is like unit which has 30 credits. Five also you have support, right? So go to HN Global and create an account, right? Create an account. Then it will be um, so here everything it is there, right? Citing, referencing and avoiding plagiarism, everything is there in order to proceed through unit 34, right? And why I was here, so if in HN Global, not only these textbooks and everything, right? Textbooks and everything. Yeah, you have a lot of other things as well, right? Here, there are like short courses. Okay, so there are a lot of things in here. Yeah, you have. So in order to do this, you don't have to pay anything, right? So this is freely allowed for yourself, right? So if you require any assistance when you're creating one, right? So I will provide to you, right? Yeah, yeah. When you go to HN Global, so you will get like create account, right? Right. Maybe some of you have access to this, right? Right. Right. We may not work. Let's see. Right. Right. Like this, you can make an account, right? So if you require any assistance, so I can provide you that as well. So, so yeah, like this, right? So you have, I think the account is creating. Okay, here. Then you will get a mail in order to verify your email account. So here, don't use a temporary email, right? So I'm just using a temporary email address. Uh, don't use a temporary email address, right? Use an email address, right? So Then here you have to fill these things, right? So date of birth and country, it is selected as select role, right? So you have to select it as a student. Right, you are selected as a student and select your center, right? uh, yeah, Sri Lanka Telecom Training Center, right? And the subjects, so you can select engineering subjects, and display name, profile picture, and everything you can do, right? So like that you can go, right? Here just need to select the center, Sri Lanka Telecom Training Center, and as a student and engineering. So yeah, there's no use if you are choosing it in another role, right? In another role, because a student will have the most privileges, because the other one, that's why the HN Global is designed for. So therefore um, you can make an account like this, right? I'll close this one, right? So like that you can create an account, right? So I recommend all of you to create an account and at least see what's uh, happening in there, right? Right, so okay, any other questions that you have, right? So then we'll continue. So yeah, if we talk about what is an embedded system, right? What is an embedded systems? So embedded systems are everywhere, right? So most of us think of desktop computers. Uh, so what is this? So this is a computer, desktop computer, right? So these are computers, right? Computers. So are they a single purpose or multi-purpose? Single or multi-purpose? So if you have any other questions, so please put it in the chat, so I will answer, right? But we will continue now, right? So single or multitask. So actually it is multitask, right? The computers that we have, they are actually multitasking devices. Why is that? Multitasking devices. So why we call them as multitasking devices is because it is not designed in order to one thing. It can do many things. It can do many things, right? So yes, yes, it can do arithmetic and logical functions. Yes, correct. And also it is multitasking. Multitasking means it has a microprocessor, right? That microprocessor, uh, so if you take like even a laptop, right? So most of them, they will have like 8 GB RAM, right? 8 GB RAM, maybe like in like i7 processor, like then 1 or 2 TB hard disk drive, so like that. So it has lot of resources, right? It has lot of resources. So if it is for single purpose, we don't need this much of resources, right? Therefore, because like i7 processing power means, so we can use this for many things. So in order to the gaming and graphical designs, and do some advanced run some advanced servers and everything also we can use, right? So therefore this is multi-purpose. This is multi-purpose. Yeah. Yes, for virtualization, so it will take a lot of memory, and also the processing power, right? So this is multi-purpose. So PCs, laptops, mainframes, and servers, these are multi-purpose because they have a lot of resources and they can do many sort of things, right? But there's another type of computing system. They are far more common, right? That is what we call as embedded systems. That is what we call embedded systems. So embedded systems is, these are also computers, right? But they are for uh, single purpose. Mm. They are single purpose devices, right? Single purpose devices. Uh, so we'll take a look why they are single purpose and why we call them as embedded systems, not computers. So we don't call them as computers. It has computing power, but we don't call them as computers, um, because they are single purpose devices, right? Right. So we consider embedded computing systems, right? So computing systems embedded within electronic devices, right? And hard to define, right? So here, other than the desktop or laptop computers, or the computers that we have explained previously, all the other computing systems, they are embedded systems. All the other computing systems, they are embedded systems, right? So there are like billions of units produced yearly versus millions of desktop units. So uh, like for like 1,000 embedded systems for one computer, so like that, right? So here, if you take any household, right, there may be more than 50 in household. Or household means inside the house, so inside an automobile there will be more than 50 embedded system inside there, right? So embedded systems are in automobile, in a camera, and inside washing machine. So so they are inside each and every device that we are using, right? um, so these are some of the embedded systems, right? Mm. These are some of the embedded systems. So here, this anti-lock brakes, right, and automatic teller machine, this is ATMs, right, and automatic toll systems, and avionic system, battery chargers, camcorders, cell phones, cruise control, digital cameras, electronic card readers, electronic toys, fax machines, fingerprint identifiers, home security systems, and embedded systems are everywhere, right? And life support systems, medical testing equipment, distance, and everywhere we have these embedded systems. So what are the characteristics of these embedded systems, right? So the common characteristics, right? So they are single function, right? Single function, that means it is designed to execute a single program repeatedly. So as an example, if we, so I'll show you an example, right? So single function, execute a single program. It is not multi-purpose, right? And here next one is, it is tightly constrained. Tightly constrained means low cost, right? Next one, it is reactive and real time, right? It should continually react to changes in the system's environment, then it must compute certain results in real time without delay, right? So if you consider like this anti-lock uh, braking system, right? Braking system, so it should work in real time, right? So it is not like so. And one good example of to identify what is an embedded system is, so something like this, right? So let's say you are using like uh, so airbags, right? Airbags, right? So the vehicle when the vehicle has been hit in a wall, so this will go into this, then this airbag, this should pop up immediately, right? Otherwise what will happen, the person who's driving in the car and the person in the front seats, they will be um, injured, right? So so this should, when this happens, when this vehicle hits to this wall, it should work within seconds, right? Within seconds it should work, right? Otherwise what is happening is, let's say like in windows, right? In a computer, in windows, right, what you will have is, if you want to delete a file, right, if you want to delete a file, it will ask, are you sure, right? Are you sure you want to delete? Yes or cancel. So like this, right? So this thing cannot happen in embedded system, right? It should work in real time. Automatically it should work in real time, right? So within few milliseconds this airbag system should trigger, right? So there won't be any asking that your permission or anything. It should work. So that is how they are designed, right? So I will give you another example, right? So if we consider simple digital camera, right? So single function, yes. In digital camera you cannot take calls or anything, so it is a single function one. It can only take a picture, so it is always a digital camera and tightly constrained. So it is small, low cost, low power, small and fast, right? So that is also correct, right? Reactive and real time, that means when you just press this button, it will take the um, it will take the photo, right? Something like that. So that is an example of embedded system. Okay, so I have a task for you, right? So list 5 embedded systems and the operation of each embedded system using block diagram. And what we call and demonstrate, right? The operation of each embedded system using block diagrams, right? So actually, uh, since we have limited time, I'm not going to give you like um, 5, right? So list 2 embedded systems and demonstrates the operation of each embedded system using block diagram, right? So that is what you have to do as the task, right? So you have to list 2 embedded systems, right? 1 and 2, right? Then the operation you have to show it using a single block diagram, and you have to draw this one, right? Draw this thing in like take a A4 sheet or just A4 size sheet, then draw these things in a single um, sheet on one side. So here first one, and this is the second one, how the operation, right? So this is the task that I am giving to you, right? So you can understand that. So you have to demonstrate the operation of each embedded system using block diagram, right? And using chat, right? Using chat, please send it to me, right? Select me and send your diagram. So this, so you can do this thing. So take a piece of paper, then a piece of A4 paper, that size paper, right? Then um, demonstrate the operation of two embedded systems, 1 and 2, right? Like this. Then take a photo, right? Then upload it to Zoom chat, right? Zoom chat, and send it only to me, right? Not to everyone. You can select where you can send the chat, right? um, Send it to me, right? So everyone publicly and me, right? So send it to me so we can understand, right? So get a piece of paper, right? Then list two embedded systems, right? So let's say this is the first one and this is the second one. So first one, draw the operation, and second one, draw the operation. Then take a photo, then upload it to the Zoom and send it only to me using chat, right? Using chat, send it to me. So I will show you one example from this, right? I will show you one example. So here something like this, right? um, mm, Here, uh, inside this, inside the refrigerator, right? Inside the refrigerator, we have we have we have a microcontroller called the embedded computer. And so what is happening is, so first after we set the required temperature, right? Required temperature, and here this will sense the actual temperature, right? So here something like this, right? So uh, required temperature, and here there should be a sensor, right? And it will sense this required temperature. Then here this knows the actual sorry, the actual temperature is sensed by, actual temperature is sensed by the sensor. So they are something like this. So then required temperature is here, right? So here we don't need to connect the sensor to in here, right? So we have the uh, so we are setting the required temperature required temperature. So then what it does is, this uh, sensor will send a signal to the embedded computer, right? We just call it as embedded hmm, computer, right? Embedded computer. Then after it sends like uh, what we call embedded computer, right? It will mm, it will check whether so like a flow chart also you can run yes or no, whether this required temperature is, so just use a book term, is equal or not, right? So if it is larger than that, right, larger than that, what it does is it will it will give you it will give you what we call a command. So this embedded computer, this will give a command to the compressor to start compression. So then it will try to reach into the required temperature right? So like that. And with this embedded computer we have to manage the human interaction, and also we have to manage the network. Maybe this is in networked interaction, so that also you have to manage, right? So uh, that is the task that you have to do, right? So I'll give you some time as well, right? So what we will do is we can take the lunch break. So now it is 12:30, right? So by 1:30 you can take the lunch break, right? Then we'll meet again at like 3 p.m., right? 3 p.m. and before 3 p.m. submit your answers using Zoom only to me, right? So there's a chat option, so submit those things, that thing before 3 p.m. to me, right? So afterwards we will uh, discuss it, right? So all of you have to upload to me, right? So make sure you are not sharing the things with you, right, with you, right? So take a A4 piece of paper of A4 size, then divide it to two, right? So then draw the operation in block